This is an example of finding volumes using the washer method. So we want to find the volume of the solid obtained by rotating the region enclosed by the curves y equals x squared and y equals square root 8x about the y-axis. And I've underlined y-axis because it's important to remember that. So I've drawn a little graph here. Y equals x squared is just a parabola. Y equals square root 8x is going to look pretty much like y equals square root x, but stretched out a little bit. So this is the region that we're interested in. Now, this intersection of the curves here is just the origin, so 0, 0. And we need to figure out what this intersection point is so that we can find our bounds of integration. So that intersection point is where x squared is equal to the square root of 8x. So first we'll square both sides. So that means x to the fourth is equal to 8x. Now divide both sides by x. That means x cubed is equal to 8. And that's going to happen when x is equal to 2. So we know that y is equal to x squared, so if x is 2, then y will be 4, and this point is the point 2, 4. So when we're doing our washers, we're going to have two radii. The little radius here I'm going to call little r, and the bigger radius I'm going to call big R. So big R comes from the curve y equals x squared. Now since we're rotating about the y-axis, we want to solve for x and get everything in terms of y. So if y equals x squared, then x is going to be equal to the square root of y. Now looking at our smaller radius, little r, we have y is equal to the square root of 8x. So then squaring both sides, y squared is going to be equal to 8x. And solving for x, x is equal to 1/8 y squared. So now we have all the information we need to write our volume integral. So the volume, we're going to take the integral from y equals 0 to y equals 4 of pi times our bigger radius squared, so our bigger radius is square root y squared, and our minus our smaller radius squared, which is 1/8 y squared times dy. So now all we have to do is evaluate this integral to find the volume. So the first thing I want to do is simplify a little bit by taking care of these squareds here. So I'm going to have the integral of 0 to 4 pi times square root of y squared is just y minus 1/8 squared is 1/64th, and y squared squared is y to the 4th dy. Now to evaluate the integral, we're just going to use the power rule. So pi, and then the integral of y is just 1/2 y squared minus, we have the 1/64th times the integral of y to the 4th is going to be 1/5 y to the 5th from 0 to 4. So first we're just going to plug in our 4. 1/2 times 4 squared is 16 minus 1/64th times 1/5 times 4 to the 5th. Now when we plug in 0, for both of these terms here, we're just going to get 0. So we can just leave that off. That's a big 0 over there. And now we'll just simplify a little bit more. Pi times 1/2 16 is 8. And then simplifying those fractions, I get 16/5. And if we combine that all together, that's going to be 24 pi over 5 is our final volume.